Hey hackers, welcome to the Azefox Innovations video on abusing capabilities, which is a part of Linux privilege escalation. So, today we are exploring Linux capabilities and privilege escalation. Capabilities are a security mechanism designed to reduce the risk posed by traditional SUID binaries. They aim to provide fine-grained privilege control, but when misconfigured, they can be abused by attackers to escalate privileges to root. So here, now, the first part is about getting started with capabilities or understanding what is capabilities, right? So traditionally, root in Linux is about all or nothing. A root user can do everything while regular users are limited. Capabilities break down this all-powerful root privilege into smaller individual units. Each unit represents one specific ability. For example, binding to low-numbered ports, overriding file permissions, or loading kernel modules. This means a binary can be granted just the capability it needs without exposing the entire system to risk. So now what's the need for capabilities or why capabilities are needed, right? So capabilities were introduced to replace the overly broad SUID mechanism. With SUID, if a binary is owned by root, any user running it temporarily gains full root privileges. This is more than necessary for the program's purpose. Capabilities solve this by enabling the principle of least privilege. For example, a network monitoring tool only needs permission to open raw sockets, not the ability to mount file systems or manage users, right? So now we'll have a look at the internal workflow of capabilities. When a binary is executed, the Linux kernel checks its extended attributes to determine if any capabilities are assigned. If so, the process inherits those privileges. Unlike SUID, this inheritance is granular. The binary only receives the specific capabilities that were explicitly assigned to it. Internally, Linux maintains three sets of capabilities for every process: the permitted set, the effective set, and the inheritable set, which control what a process can do and what it can pass on to child processes. So here we will have a look at capabilities versus SUID binaries, right? The key difference between SUID and capabilities is the scope. SUID effectively hands over all of root's powers, even if the binary needs only one. Capabilities are more precise, granting just a slice of privilege. However, the precision only works if administrator assign them carefully. A binary without the SUID bit can still pose a serious threat if it is given a dangerous capability. Attackers increasingly look for these misconfigurations as they are less obvious than SUID files. So here is a list about some of the common dangerous capabilities. Right, not all capabilities are equally risky. Some are extremely dangerous because they allow a process to bypass core control security controls. So the first one is the capsys admin, which is like the most notorious one. It's so broad, it's often described as the new root. It allows mounting file systems, changing kernel parameters, and even creating namespaces. The second one is the cap setuid, which actually allows changing the process's user's ID to root, effectively bypassing access control. The third is about cap sysp trace, which allows attaching to and controlling other processes, including those running as root. The last one, which we're going to have a look at, is the cap DAC override, which actually allows opening access to sensitive files. So now we'll talk about the risk and exploitation of capabilities, right? So when capabilities are misused, capabilities become a subtle, powerful escalation path. Unlike SUID, which is easier to spot, capabilities can quietly enable binaries to bypass restrictions. Attackers may use them to read sensitive files, inject into privileged processes, or elevate to full root. Because some capabilities like capsys admin cover such a wide range of operations, a single misconfiguration can expose the entire system to take over. So now it's the demo time for you know for the capabilities, and before that we will have a look at the GTFO bins site. So GTFO bins is a really good site, generally used for privilege escalation purposes, especially for Linux binaries, right? It has a wide range of options or wide range of capabilities here. For example, shell, command, reverse shell, and etc. etc. Bind shell. even we have the SUID bit and also the capabilities which we are going to abuse in this video, right? So first let me go to my Kali machine and paste the IP here, and 1 second. Yeah. So now I have a user here as current, right? I need to now escalate the privileges to root. So now how you can enumerate for misconfigured capabilities, right? For that we have a command known as getcap, right? So we have the getcap -r, and we can redirect the error messages to this directory. And as you can see, we have a lot of capabilities being listed out here. And in one of the in one of the capabilities we have Vim listed out here, like, which means that we can use the Vim binary, right? So Vim binary is actually a text, it's actually a text editor, used on Linux operating systems, right? So we can use Vim, right, and we can escalate our privileges to root. Okay, so now how we are going to escalate the privileges, right? For this we have the GTFO pins, right? Here I can type Vim here, right? And you can see it actually lists out all the operations that can be performed using the Vim binary, right? For privilege escalation purposes. So now we have the capabilities here, and it actually gives you, the way, it actually gives you the code or the command to execute in order to escalate the privileges, right? So what we will do, we will just copy the binary or copy the line, command line, which we will need to escalate our privileges, right? Just paste this. So what this command does, it's actually using Vim to execute commands, right? Which is actually like spawning the shell here once again using the Python command line, right? And once done, it will actually give us a root shell. So before that, you know, we need to set this to Python 3, as I previously enumerated the machine. It doesn't have Python 1, it actually has Python 3, so we need to change this to Python 3 here, Py 3. And if I run this, as you can see, we got a shell here, right? So if I use id, we are no root here. Okay, so I can directly go to the root directory here, ls, and we can go to the root directory, ls, right? And after that we have many of the directories, right? So yeah, this is for this video. So yeah guys, this is for this video, right? I will catch you all in another new video, right? Until and unless, bye bye. And before going out, make sure you follow and subscribe Azefox Innovations for more innovative videos.